Right, here I am again, this time with a video on topic 4.5. Now, this topic can be divided into three parts: the greenhouse effect, mass spectrometry, and infrared spectroscopy. Now, to try to do all of that in one video will probably take too long, so I think I'll just do this video on the greenhouse effect only, and then do the other two parts in a second video, which I'll post as soon as possible. Okay, now the first point to make is that, as shown here, molecules vibrate around their covalent bonds, and they vibrate at all times. However, when they absorb infrared radiation, they start to vibrate faster. At this point, I want you to pause my video and watch the first two videos I've sent you in the email. Come back to me when you're done with those. Right, next thing to remind you of is that on Moodle there is a topic 4.5 notes PowerPoint, only a short one. As usual, open that PowerPoint and copy the contents, please. Now, the second slide of that PowerPoint is shown here, and it mentions three gases responsible for causing global warming. These are the three that your exam board wishes you to know about. Really, there are 5 gases responsible, but as these are the only 3 you need to remember, we'll stick to these 3 in the notes. I'll mention the other 2 in a minute anyway. Why do these gases cause global warming is the next question. Now, hopefully, as you've picked up from the first of the videos I sent you, it is for molecules to be able to absorb infrared radiation and vibrate more, they need to have polar bonds, and all 3 of these do indeed have polar bonds. They don't need to be polar molecules, but they do need to have polar bonds. Opportunity for a quick bit of revision here actually. Why does carbon dioxide have polar bonds? Pause the video for a few seconds and say the answer to yourselves. Answer is, of course, that carbon and oxygen have different electronegativities. Now, it's not necessary, by the way, for the molecule itself to be polar. After all, 2 of these 3 molecules are not polar molecules. Again, pause for hopefully about half a second and shout back to my video which molecule is polar. Right, don't even need to tell you the answer to that one. But, as I say, all you need is polar bonds. And that, by the way, in case you were all thinking, well, if, bonds can absorb infrared radiation and vibrate more, why don't the 2 main gases in the atmosphere also cause global warming? Nitrogen and oxygen, of course. Simple answer to that is that they are not, or they don't have polar bonds, and therefore they do not absorb infrared radiation. All 3 of these do, however. Well, we'll have a closer look at how the greenhouse effect is actually caused now. Right, here's a nice little image. Now, solar radiation from the sun reaches the Earth. It causes the surface of the Earth to get hotter. Because the surface of the Earth gets hotter, it actually radiates infrared radiation back out into space. And quite a lot of that infrared radiation duly escapes into space, but some of that infrared radiation is absorbed instead by greenhouse gases in the atmosphere. When those greenhouse gases absorb that infrared radiation, they vibrate more, meaning their kinetic energy increases. And if their kinetic energy is increasing, they are, of course, getting hotter. And therefore, they cause the atmosphere to warm up. Now, it's worth stating next that the greenhouse effect is not in itself a terrible thing. Depending on what source of information you read, without the greenhouse effect at all, the Earth would be anything from about 20 degrees to 60 degrees cooler than it is at the moment, meaning there would either be a lot less life on Earth in a lower portion of the Earth's surface, or no life on Earth at all as we know it, possibly. So the greenhouse effect is not a terrible thing. We just don't want too much of a good thing either. Now, let's come back to those gases which cause the greenhouse effect. Now, if I were to ask you which gas is chiefly responsible for the greenhouse effect, you would probably all shout back at me straight away, carbon dioxide. And I would shout straight back at you, well, you're wrong, you fools. It's actually not. Did you know that 95% of the greenhouse effect is actually caused by water vapour? There you go, just to confirm. Now, if water vapour is the main greenhouse gas, why are we all up in arms about the amount of carbon dioxide in the atmosphere and not about the amount of water vapour? After all, if you burn fossil fuels, both carbon dioxide and water vapour are emitted. So perhaps we're right to be concerned about burning fossil fuels, but why do we focus on the CO2 and not the water vapour? Well, the answer to that question is, firstly, to state that the amount of water vapour released by human activity really is tiny compared to the amount of water vapour that enters the atmosphere just by evaporation from the oceans. But you could still argue, well, yeah, but if we're still adding a little bit more, isn't that still adding to the problem? And doesn't it accumulate over time, the amount of extra water that we are adding? The answer to that, fortunately, is no. It doesn't add to the problem because the Earth's atmosphere can only hold a certain amount of water vapour, and if we release extra water vapour into the atmosphere, it just condenses out and falls back to the surface as rain. So any extra water vapour that we add to the atmosphere from our activities is literally drops in the ocean. So water vapour doesn't really matter. Here are the four main greenhouse gases that do matter. Got their concentration in the atmosphere in parts per billion to make the figures manageable. And that's which one? We've got a multiplier or a global warming potential. What that actually means, for example, is that one molecule of methane absorbs 21 times as much heat as one molecule of carbon dioxide. And nitrous oxide and CFC is even worse, as you can see. Now, of these four greenhouse gases, if we are to work out which of them is the biggest contributor to the greenhouse effect, well, you need to complete this table, really, the final two columns. The total relative contribution column is literally do exactly what it says, do the concentration multiplied by the GWP. Once you've got the four figures in that column all completed, you can work out a total for that column and then convert them into a percentage. Pause the video and have a go at that. Well, this is what you should have found. Although in terms of the amount of infrared radiation or heat that it can absorb, carbon dioxide seems the most benign. Actually, it is still the main contributor to the greenhouse effect, and therefore we are right to single out carbon dioxide for the greatest amount of attention. But we do still have to be worried about the other sources. Nitrous oxide also largely comes from vehicle engines. Planes release a fair bit of it, but as do all vehicle engines. Diesel's worse than petrol in terms of nitrous oxide, although diesels, on the other hand, do release less carbon dioxide than petrol. Methane, several sources of that. I mean, apart from natural sources, the main sources are flatulence by ruminants, chiefly cows, which is one reason why we're all encouraged to cut down or cut out meat consumption altogether to reduce the impact of global warming. Or the other place that methane can come from actually is when food waste is buried in landfill. If food waste is just composted or thrown onto a compost heap or allowed to decompose in the open air, it decomposes to carbon dioxide. But if it's buried in landfill, it decomposes in anaerobic conditions and decomposes to methane, which is why many of you may have found big yellow stickers plastered all over your wheelie bins, as I did, saying no food waste, please. A move I totally agree with, actually. I like to have a compost heap in my garden myself and throw all my food waste on there. So I was a bit aggrieved when I first saw these yellow stickers in my bin a couple of weeks ago. But I quickly noticed everyone on the street had them, and maybe many of you have as well. And it's a good move. We should not be putting food waste in with our general rubbish because it will add to global warming if we do. Anyway, however, carbon dioxide is the chief culprit, as you can see. CFCs, by the way, also in that table. I should mention them for a couple of reasons. One, they, of course, are gases with double jeopardy. They cause ozone destruction and global warming. As I did mention to you before the closure of the college, CFCs are no longer really being emitted anymore in any significant amounts, but they are still up there in the atmosphere, so they do persist for a long time. Now, which leads me on to another point about not confusing ozone destruction with the greenhouse effect. The ozone layer becoming thinner or even developing holes in it means more ultraviolet radiation reaches the Earth's surface. The role of the ozone layer is to absorb harmful ultraviolet radiation and stop it reaching the Earth's surface, where it can cause problems such as mutations in skin cells which lead to cancer. It can also harm and even stunt the growth and even kill plants, too much ultraviolet radiation. However, it's nothing at all to do with the greenhouse effect, the ozone destruction. Some people wrongly think, because the ozone layer is getting thinner, more ultraviolet radiation is hitting the Earth, causing the Earth to get hotter. No, ultraviolet radiation does not cause the Earth to get hotter. So don't confuse the two, please. Another couple of things to mention quickly. The greenhouse effect and global warming, are they two names for the same thing? Not quite. There is a subtle difference. The greenhouse effect is the name given to the trapping of infrared radiation by greenhouse gases in the Earth's atmosphere, as shown there, stopping the infrared radiation, in other words, heat from escaping. That is the greenhouse effect. The fact that the infrared radiation is trapped by these gases causes global warming. So in other words, the greenhouse effect causes global warming. They're not quite words for the same thing. Another question that people sometimes ask is, well, if these greenhouse gases can absorb infrared radiation, how come they don't absorb the incoming solar radiation? How come they only absorb it when it's leaving the Earth and going out to space? The answer is actually they do absorb some of the incoming solar radiation, as mentioned just there, actually. But a lot of the solar radiation is of different wavelengths, and therefore they only absorb sort of a small portion of the solar radiation reaching the Earth, the small portion of the incoming solar radiation, whereas they absorb a much larger portion of the outgoing infrared radiation. All of the outgoing infrared radiation is of the right wavelength to be absorbed by greenhouse gases. Much of the incoming solar radiation is not of the right wavelength to be absorbed by the greenhouse gas. Right, final couple of points. So one positive note, shall we? We're all having to get by with the college being closed and do our best to get through all the disruption to our lives caused by the coronavirus. But always a silver lining to every cloud. China's CO2 emissions are down by 25% since this crisis started, and I suspect much of the rest of the world is quickly following suit. And I was actually reading today that it's not just the CO2 emissions that are reduced in China, it's general air pollution. And air pollution in China is estimated to kill 1 million people a year, and therefore the reduction in air pollution is estimated to have saved 50,000 lives in China alone already. As I say, always a silver lining. Final thing to mention, many of us, I'd like to think that many of you do care about global warming and would like to see the problem brought under control. Up to now, it's probably correct to say that we humans have really been rather poor at confronting this problem. Largely, we've met the problem with a shrug, and it's quite common for many people to just blame politicians, world leaders, industries for this, and why aren't you doing anything about this? Can't you see polar bears are dying? Our planet's getting warmer. Future generations are under threat. Why aren't we taking action? And then promptly getting in their car and driving down the road when it would have taken them 5 minutes to walk it. If you do really care, and I'd like to think that you do, by all means protest to our leaders, to industries, but don't please be a hypocrite. In the words of the great Mahatma Gandhi, be the change you want to see. Or perhaps, to quote the perhaps not quite so great Michael Jackson, start with the man in the mirror, or the woman in the mirror, of course. And if you really care about global warming, begin by reducing your own impact on the planet, please. Okay, that'll do for this video. I'll bring you another one as soon as possible on the rest of the topic. Okay, bye for now.